Thank you again for being here. We're very glad to be in Athens, and our first meetup with Elastic. We have done this presentation some more times, but when we start a presentation, let's say we are thinking of telling a story in order to see how we can combine with the audience and have something going. But the truth is that we are very glad to be here because we feel that we share the same problems here. We are both developers. Yes, I'm not a manager. It's an internal joke here, but the thing is that we don't need to tell anything because we are going to share and work on today about the common problem that we had in our work. And one thing that we need to underline here is that all the code and all the examples that we present here are open source. All the code is open source, and we're going to share all the examples for you. And please come again and share your thoughts and your development experience after this presentation. Let's start. Let's position our presentation today. Let's see what is our main problem. And as the main thing that we try to understand today is how we can see the health of our system. We can get logs, metrics, and traces from our system. We need to store them, and from all over the place, we need to find ways to retrieve this information and understand proactively or maybe late enough to understand the health of our system. So we are going to talk for observability. Yes. The agenda for today is that, okay, I need to understand the health of my system, but why I need to use this term? So the first thing that we are going to talk here is the term of integration. We are going to introduce you the term of integration and see how this combines with the general problem of observability. We're going to talk about the Elastic Package tool, which is a specific tool that we are going to use inside Elastic in order to create integrations. The first thing that we are going to speak today. Then we're going to see how the Elastic agent leverages both of these things, the Elastic package and the integration, in order to collect this valuable input. And all this configuration, all these policies, all these steps that previously are manual, we're going to see how we can automate all these actions from the developer side. So in our example, is based on Elastic technology, but we think that we provide, and we are going to speak for technologies that are general enough, that everyone uses, so the best practices of the technologies and tools that we use, we think that can be exposed to more general problems, and probably we can touch some of your needs, and maybe we can have also time later to talk for them. So this is Elastic Stack, okay? I showed many heads before about how many people are using Elastic, but some people think that Elastic is only our database, some other people think that Elastic is only our visualization, but in order to see, this is, let's say, in general terms, our portfolio. And to combine the stack with the initial problem that was, let's say, if we want to understand the health of our system, then we need to collect the information for step one. We need to, after the collection of all information that happens with either with bits or Elastic agent or with logs, we need to ingest all this information inside our database. And we are talking about Elasticsearch, the NoSQL database, blah, 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 that is inside our stack. And then after we store all this information, we can retrieve this information through Kibana, the visualization part. And then we can see how we can do aggregations, more, let's say, complex things in order to read the information we have stored. What is integration after all? And how this term combines with our initial problem? Elastic integration or Elastic package. We can see all around documentation that this term is used a little bit freely, let's say, but it's the same thing. So Elastic integration is a set of definition. So it's a set of rules, let's say. And we need to give information to Elastic agent, to the card, to the tool that we have in order to collect the information. We need to give information to the Elastic agent what information to collect. So the set of definitions that we give is the Elastic integration. It's just the same as that. So it is different ways of configuring Elastic agent. If I have a system and my system equals to a Linux machine, and I need to collect lots of metrics from a Linux machine, then I need a specific configuration for my Linux machine. If I have a database, I need a specific configuration for my database. This is an integration. You can find the official integrations under /elastic/integrations. So you can find a full list of our integrations. So for example, you can find like Redis integration under /Redis folder. And assume inside the folder of integration, you can find a specific structure the slash dev build folders, the image, the Kibana folder, things like that. So I didn't stay on purpose on the previous description of what is an integration and read the information again, but again, I don't want to speak too much in details because a set of definitions can be not only the configuration of the agent, can be also dashboards, can be Kibana dashboards, can be documentation, can be tests. So yes, we can define all of these things as part of the configuration of the specific, let's say, system that we want to observe. So yes, we have integration, but can everyone create integration? Can everyone write integration? I think yes, because it is a YAML file. So you do need to write a code. We provide, let's say, more or less the abstraction. Everyone follows a YAML structure, and the YAML structure needs to follow a specific specification. It's specific. So you can find specification, so you write your YAML structure in specific, let's say, structure, and this means that it will translate quantity backwards to Elastic, and it will create the visualizations, the documents, tests, all these things. So when all this configuration comes from the developer side, then the built version of your Elastic integration lives in a storage repository. So every time that you create an Elastic stack, you don't need to recreate the integration. You just point to the repository and you download the package that you have built before. So this way you can create multiple versions of the integration. It's a zoom of the specification. So inside the integration folder, you can find the data stream folder, you can find the /dev folder with the tests, the Kibana folder with the assets of visualizations that we can describe. Are you familiar with the term data stream? Shall we give a little bit more focus on what is a data stream regarding observability? Shall we talk, anyone who knows about what is a data stream? Or can we analyze the wording here? So it's a stream of specific data. So if you want to say to our integration, let's say I'm talking about /Redis integration that I mentioned before. So the Redis integration can have logs. So I want to collect logs. So data stream, one data stream can be my logs data stream. Another data stream can be my metrics from my specific endpoint of Redis. So inside the integration, I can create multiple data streams. This way I can, let's say, in one place I can enable only one data stream in one configuration. Or in another scenario, I can enable the other data stream. So this way I have the flexibility to play with my configuration. Okay, all these previous steps can be done manually. We are developers, we know that we can write the YAML, I think. So after all, what is it about? So it's a YAML guy that, or we only write YAMLs later. So we introduced the Elastic Package tool, which can help us create an integration. So another layer on the developer experience of integrations is the Elastic Package tool. You can find the Elastic Package tool under /elastic package tool. You can download on your machine. There are built versions. There is the source code. You can also build in your machine. So what is Elastic Package tool? It's a GoCLI tool. Just like that. It can help you build, create integration, format, generate the structure, the previous structure that we mentioned with the folders, with the streams. So you don't need to make the same errors. Maybe you misspell a folder. Maybe you don't write a specific, you don't include all the needed files inside the folders. So Elastic Package is here for you to lean format, create the folders for you, and also we keep enhancing the tool in order to help us test things, in order to create stuff. We will see run specific tests inside the integration. So this is a tool to help developers. And let's go to our first demo for today. Check. Okay, can you see the font? As you can see, I'm inside /integration/packages folder. One sec to go. One. So this is a full list of packages, a full list of integrations that someone can find inside integration. So you can go inside the GitHub, you can download pre-built already existing integrations for you. And we think that we match the major scenarios of configurations for your systems out there. So you can find scenarios for cloud infrastructures, for databases, for programming languages, all kind of things. And let's use the Elastic Package tool in order to create a new version of integration. As you can see, okay, can you hear me? You can still hear me, I hope. So this is the structure folder inside the Elastic package, inside the specific integration package, the Kubernetes package. And what I'm gonna do is that I'm gonna copy paste in the change log. I will create a new entry. I will call it version 142.1. I'm gonna give it a different, let's say, title here. I'm gonna go to my manifest YAML file. My manifest YAML file is the main file of each integration. So inside all integrations, the first file that is being read is the manifest.yaml file. And when each integration starts reading the manifest, and then from the manifest, it understands all the underneath structure that is inside the specific integration. And I will go, for example, do you see inside my data stream folder? You can find inside Kubernetes integration, we have multiple data streams, meaning that I have a specific configuration in order to collect logs and metrics from IP server. I have another data stream called containers that I collect logs and metrics from containers. So you can find multiple folders, and then you can find different configurations for each data stream. So I can go inside my state pod, for example, data stream, and I want to change the title. Let's say I will write here leader election test. Okay. So let me go back to my folder. Check. So I'm inside the integrations folder. I'm building the new integration. If I had done a mistake, then the tool will inform me that I don't follow the specifications, an error will report back. But as you can see, the Kubernetes version that I have created has been built. So I will use the Elastic Stack app command. Again, is a subcommand of Elastic Package tool, and I want to create a specific stack, Elastic Stack, in my localhost machine. So what is Elastic Package doing right now? Elastic Package right now acts as a wrapper of my Docker. It spins up specific Docker containers for all the system modules of Elasticsearch. So you can see this is the Elasticsearch that spins up as a Docker container. This is the package registry that we talked about. It is a local version of my package registry with the new integration that I have created, the 1.42.1 version that I have created, Kibana, and so goes on. So when Elastic Package will report back that all the systems are up, I will go back to my browser. Give it 1 sec. Okay, so this is the main page of Kibana. It runs in localhost, as you can see. So I can go to my integrations. You can go from here either or from the burger menu right here. I'm going into the extensive list. I type for Kubernetes. I'm going here. You see the latest version right now. It is 142.1, the one that I have built it locally. And let's see our versions. Let's see our changelog. This is a test that the changes that I have made. And if we go, let's say, inside the configuration of my integration, let me scroll a little bit down. I can show you here that, do you see here that there are different data streams? So each folder that you saw before inside my folder corresponds here to a different data stream configuration inside Kibana. And let me open and find my state pod data stream. And do you see, this is the title that I have changed to test. So what I did, maybe the demo is not so fancy, but what I did is that I have the folder structure already ready. I have the Elastic package ready. I have all the tools, so I don't need to do all the manual steps and I don't need to understand too many things from the specification. So I use the tool and I automate as first step also the Elastic stack locally, and I can test all my changes here. Let me bring the stack down. In order to be ready for the next demo, and we're gonna go back to the presentation. And I'm gonna give the pass to Chris to continue for.
Thank you. It's really important to understand that if you want to extend the Elastic Stack, you have all the tooling available so as to create new integrations, or as Andreas showed us, to extend the ones that are available already. If you are a developer, you want to create an integration, or you want to upgrade or update an already existing integration, you have Elastic package. So you can use Elastic package to bring the stack up, to do everything, to develop, to test your integration. And then you can push it to the repository that Andreas called us before, and everything is easy. So now we'll see how this small unit, this integration, this package as we called it, can be put into real action and actually do the work for us. So far we have seen the developer part. Now we will move more to the ops part, and let's see how the DevOps board uses these things to do the observability thing and the monitoring thing. So in order to get our data into Elastic, we need Elastic Agent to work along with the integrations. So what is Elastic Agent? It's a shipper, a collector, name it whatever you want. And it's really similar to what Bits was in the past. Yeah, I have this thing all this time, okay. So it's really similar to Bits, and it's the new generation of, let's say, shipper for Elastic, and it's really similar to Bits for log collection and host monitoring. And let me ask you here, how many of you have used Bits in the past, or you are still using it? Okay, and how many of you are using Elastic Agent already? Okay, fair enough. So Elastic Agent is really similar, but it comes with several advantages compared to Bits. And yeah, it's one single agent. So compared to Bits, with Bits, if you want to collect logs, you need FileBit. If you want to collect metrics, you need MetricBit. If you want to do security metrics collection, you need PacketBit, for example. So you have multiple agents for multiple bits, to be specific, for multiple different reasons. So with Elastic Agent, you only have one single one. This makes it easier for you because you only have to deploy and manage one single agent compared to multiple ones. Also, it's easier to configure Elastic Agent because we have all this tooling. We have also one configuration file that we need to version control, maintain, and everything, compared to having multiple configuration files for the multiple bits that we need for our use cases. And last but not least, you have the option to centrally manage your Elastic Agents, because Elastic Agent can run in two different modes. We have the fleet managed mode, which means that your Elastic Agents, when they are installed on your machines, they have the option to be enrolled into a fleet. So you have a group of agents that you can centrally manage them through Kibana. You can upgrade their versions, you can push your configurations to them, you can install new integrations like these that Andreas was talking about before. So this is the fleet managed mode, and then you have a standalone mode that we will talk more later, where the developer, the DevOps, the SRE needs to maintain everything on their ends and take care of the configuration files and everything. And we will see how it's useful. So an overview of how Elastic Agent is installed on infrastructure. Let's say either you have bare metal machines, or you have virtual machines, or you have Kubernetes clusters. You need Elastic Agent to be running on these endpoints, and Elastic Agent will be communicating with Elastic Stack. Either Elastic Stack is running outside into the cloud, or it's running in the same infrastructure with the one that you want to monitor actually. So it will communicate with Elasticsearch to send data, it will communicate with Git server to get upgrades about the configuration, to report the status and all that stuff. Let's see how it looks like. So the fleet view within Kibana looks like this. You have an overview of your agents that are enrolled. You see the version of your Elastic agent. You see their status. You see also this one here, the Elastic agent policy, which is actually the configuration that agents are related with. So they fetch everything from within this configuration. Either it is connection information, how to connect to Elasticsearch, which secrets to use, which integration to enable, which inputs, and so on. And if you want to to extend your configurations, for example, and you want to use the integration that another team built for you, or you have built it already, you can go to the integrations page and search for the integrations that you want, and then let's say that I choose to install Redis on my the Redis integration because I want to collect Redis logs and Redis metrics. So I will see this view here, and I will see a nice form, and I can set all the information that I want for my integration, which means that I will set the endpoints to collect metrics from network-related settings, the path from where to collect the logs and all that stuff. So what happens here? The Kibana side will fetch from the upstream registry the package, the integration that someone else has built already, or I can be the same person that built the integration or the package, and it will translate the spec, the file that Andreas was explaining us before, into this nice view. So it makes it easy for us to populate the configuration instead of dealing with the YAML indentation and which, for example, which defaults to use and all that stuff. So it's pretty much easier to use this way. And in the end, Elastic Agent will receive a pure YAML, let's say, blob, configuration blob, which looks like this. So here I specify which integration to use, the type of the integration that I want to collect metrics, which secret to use under the hood, where is the metrics endpoint that I need to use, and integration-specific settings like which network, which period to use, set the max number of connections, and everything that is specified within the package, within the integration, will be available here. So we call this small piece of this small configuration block, we call it integration policy. And a bit of terminology, because it will be useful for later for the demo. The integration policy is just this, the integration specific configuration. And if we have multiple integrations installed, we will have multiple configuration blocks for each specific integration that we have. And then multiple integration policies will create the final agent configuration, which is the agent policy that I mentioned before inside the Fleet UI. So an agent will be related to an agent policy, and it will be getting all the information about the settings from this policy. And yeah, if I go and I want to inspect my policy, my Elastic Agent policy, I will find something like this. It's a YAML file, so I can tune it accordingly if I want. I can change it manually, and I can download it, for example, and take it on my side, let's say, and then I can run Elastic Agent without enrolling Elastic Agent to Fleet, and having Elastic Agent to using the policy that I have downloaded. So the story here is that I can use the UI to specify the integrations that I want to enable and gain some time out of this because it's easier. And then I can take the configuration and version control it, for example, and push it into a repository, use tools like Argo CD to automate my deployment process and all that stuff. Standalone mode is really useful when you have, for example, security constraints, or if you don't want to use the user interface to do DevOps things, and you want to do it everything using your own tools, using GitHub, for example, and other tools that can help you. So now we will see how all these work together with a real example using Argo CD to deploy Elastic Agent in Kubernetes and automatically retrieve configuration files from a GitHub repository. And yeah, it's Andreas time.
Thank you. First explained here that all these steps can be done manually. And what do we mean about all these steps? We mean that we need to observe our system. Okay, so I create configurations, I create integrations, I create agent policies. Then I combine the agent policies and I install an agent. Then I install all these agents to all my Kubernetes pods. So all these steps can be done manually. Yes. This is the nightmare of you can do this well. Even if something happens, then you need to go inside and shoot, you can see what is happening. So yes, this is the UI. You can do all these steps from the UI. The UI is another, let's say, wrapper for manual steps, but okay, it's not an automation. So for manual steps, we try here to propose a GitOps approach. It's a function word, okay, I know it's, if you want to take out, let's say, the function words, what we try to do here is that we want all this configuration YAML files to live inside Git, and if we want to deploy and do all these manual steps that we mentioned before, to use some tools to do it for us. The choice of the tools is Jenkins and Argo CD. Jenkins, in our case, is used to retrieve the initial code from Git and do the configuration inside Elasticsearch. Then Argo CD is the tool to take the manifest and install this manifest inside the Kubernetes cluster. Because as you have seen before, the problem, especially if we are talking about observability, is a double now, let's say, because I need to create the configuration first, and then I need to install my agents. I can have a big talk here about choice of the tools. Jenkins, yes, can be replaced with whatever other build guide, whatever you want. The choice of programming languages, we use Python underneath, because we need to create and run some API calls to Kibana and to configure Kibana. Maybe the API calls can be directed to calls. But again, the choice of the language can be data, but again, this is choice. This is a discussion about the best practices here. What I'm trying to say here is that let's try to find a solution in order to do this, all of this automatically. Again, I'm saying that the schema, even the guide to install all this information locally in your machine is online. You can find all the references here, the documentation. So please take it afterward and play with this code, and let's do a dry run of this code today together. So let me go again here. So this is my cluster at the moment. Okay, I have a local cluster here, just to believe me that no Elastic is running here. So nothing regarding Elastic runs in my cluster. As you can see, I have installed also Argo CD in my cluster in order to avoid authentication issues. So Argo CD will read the manifest and will install this manifest inside the same cluster in order to avoid authentication issues. But of course, you can install Argo CD wherever you want. You can install your manifest towards to whatever remote Kubernetes cluster. But again, for simplicity, I have done it all this locally here. Let me first run again the stack up command that I did before. So I create a brand new Elastic Stack with a specific version. I should have done before in order not to wait, but it's not going to take too much time. For your information, the Elastic package, as we said, is a wrapper for Docker. It will download, first time that you will run it, it will download the versions of the images of the specific version that you try to install. So maybe the time on your first run will be a little bit bigger, but again, the next time it is faster. Okay, one sec. So this is my, let me find also my code for Argo CD. Again, all these steps you can describe inside. Okay, this is my Argo CD. Let me show you, this is the GitHub folder where all the configuration for Jenkins lines inside the GitHub repository. So even Jenkins reads as a SCM input those Jenkins files. So you will see that my Jenkins pipelines here also have a reference to Git. So I have no configuration inside Jenkins, even these configuration lines in Git. And this is where a manifest of ours will be created after our automation, and this manifest will be installed in my local cluster. I hope that my cluster is up right now. Okay, so I log in again. It's the default password of Elastic. Okay, let me in order to. So this is the screenshot that Christos was showing before. Inside my agents, you can see all the default agents, only the default agents. These are the fleet server agents that are by default installed in order to be ready to retrieve and are ready to hear any incoming requests for any other agent that they want to enroll in my Elastic Stack. So no other agents have been installed. Also, only the default policies are inside my configuration. What I'm going to do here, just to demonstrate you this functionality, I'm going to create an input, a different input in my Kibana. And what does this mean? That this is the agent here. So all the data are input for the agent. The agent sends all this information to Elasticsearch, and then the output is configured here. So you can find the output, and then from this point here, you can send the information, you can save it to different Elasticsearch instances. So I'm gonna take this one, this URL here, I'm gonna create a different output, I'm gonna give it a name, just the same, and I'm gonna write a specific configuration just to create this. So what I'm gonna do here, because this is a local cluster, and sorry, typo, my certificate is not an authenticated one, so I want to override the SSL verification. So I'm creating the new output. The new output has been created. If you can see that all entries inside Elastic have a specific ID. So what I'm gonna do is that I'm gonna go to my agent policy, and these are the files that Christos mentioned before. This is the agent policy, this is a Kubernetes policy. So we have the agent policy and also the integrations policies here. So I'm gonna edit the file. I'm gonna copy paste my new output. Okay. And the next thing that I want is I want a way to authenticate my Jenkins to authenticate to Elasticsearch. So what I'm gonna do is I'm gonna go and create, sorry for that, I'm gonna go and create a unique token that Jenkins will use in order to authenticate to Elastic. This is a token with specific, let's say, administration privileges here. So I'm gonna go to my Jenkins, I'm gonna go to credential store, I'm gonna change the token that I had before. I'm gonna save this one, and I hope that the demo guide will be with us today. So I'm gonna start the Jenkins installation for the agent. And what we have configured right now is that the Jenkins will try to read first the SCM pipeline from the Git pod, so it will understand what it needs to do. It will read the agent policy, the Kubernetes integration policy, and it will create the manifest for us. So the first Jenkins job here, as you can see, it will trigger a second one. So we also inside the demo, it's not, we don't have time, but also we demonstrate the use of a second pipeline. So we call from one Jenkins pipeline a second pipeline. Okay, it's something common, but also you can find it as part of the demo. So both of them have run successfully. And let me go back to my configurations. I'm going to fleet. I'm going to my agent policies. And as you can see here, the new policy has been created. And do you see, this is the Kubernetes configuration that I have created before. And also, if I go to the manifest right now, do you see that the new manifest has been created here? The manifest that I need in order to install the agents in all my clusters. So if I wait here, Argo CD can be configured to automatically read every specific time. Just because we don't have time, I'm gonna click a refresh here. So this one understands that a new manifest has been uploaded to a specific folder, reads the manifest, and installs the new manifest inside my cluster. Let me see if we have an Elastic. Yes, and we have an Elastic agent inside my, oh, sorry. So we have an Elastic agent here running, and let me go back to our agents. Do you see the agent has been enrolled? And imagine here that I have only Kubernetes cluster. Imagine that this one, if I had a cluster with 10 nodes, 15 nodes, this would install 15 agents right now, all enrolled all ready to kick the configuration from within here. But the interesting thing is also that if you go to Discover right now, let's go, this is where I can find my metrics. Do I collect metrics anymore? And you see that I have started receiving metrics from my system right now. So what we have done, what we have automated is that we have automated all the steps that we have talked before, the agent policy, the Kubernetes integration configuration, and all these things. Just for the sake of the demo, let's do also an update, for example. Maybe we can go here. Let me show you the specific configuration. So in my integration, what I have is that the agent policy that I have right now. So if I go to my policy, you will see that I have enabled the kubelet API. So I retrieve metrics from kubelet, the kube state metrics, and all these things. Imagine that for some reason, I don't want to receive metrics for a specific endpoint. And I want this configuration to ship all my clusters. So I go to my GitHub, I update my policy. I will kick off the update. It's a different pipeline because I call the same Python script underneath with different configuration. That's why all these things can be done with the same pipeline if you want, but it's the same thing. So if I go back to my policies right now, that kubelet now has been disabled. And okay, we can run the same thing we can delete the same things and things like that. We try to summarize the basic takeaways for today. Okay, everyone has a system that wants to move. How we can code around the scenarios with integrations, different integration for different systems. I am a developer. Can Elastic help developers create integrations? Yes, with Elastic pipelines. Can I combine all these different configurations inside the Elastic agent? Yes, I can with policies. So Elastic agent with different policies can include different integrations. And we have different versions of Elastic agent. The managed one, the standalone one, so we try to cover different scenarios. But what it remains is that all this configuration is manual, so we need, and we try to give today, let's say, the approach with GitOps and with the live example how to approach this and solve the problem of automation. As I said, some references, all the code is free, also the demo and the POC and the documentation.